Okay, so subtopic 11.2 radioactivity. So 11.2a explain alpha, beta plus, beta minus, gamma decays. Radioactive decay as the spontaneous and random process introduce neutrino and antineutrino. First, we look at radioactive decay. So definition is defined as the phenomenon in which an unstable nucleus disintegrate to acquire a more stable nucleus without absorbing an external energy. So the radioactive decay is spontaneous reaction, unplanned, cannot be predicted, independent physical condition and chemical change. The reaction is random reaction because the probability of the nucleus decay at the given instant is the same for all the nuclei in the sample. So this is radioactive radiation emitted when unstable nucleus decay to be alpha particle, beta particle and gamma ray. So beta particle we can consider into two types. First is beta plus and the second one is beta minus. Okay, so first we look at alpha decay. So what is alpha decay? Alpha decay, dia akan emit alpha particle, okay, symbolized as a alpha or 4,2 helium. So a strongly bound system of 2 proton and 2 neutrons. So alpha particle is a positive charge and the value is positive 2e with the mass of atomic mass is 4.001502 U. Okay, when the nucleus undergo the alpha decay, it will lose 4 nucleon and 2 of which are proton. So therefore the reaction can be represented by general equation as below. So ni kalau kita tengok persamaan kimia ni, kalau reaction punya persamaan ni, you akan tengok mass number dia dengan proton number before and after reaction adalah kena sama. So selebihnya dia akan jadi sebagai emitted partikel dia. So awak tahulah yang selebihnya akan jadi emitted partikel apa. Kalau 4,2 dia akan jadi 4,2 helium. Okay, so macam itulah. Ini adalah alpha decay. So next is a beta decay. Beta decay was initially associated with the emission of an electron. So the beta particle, it was later discovered that some nuclei can undergo beta decay by emitting a positron. So sebelum ni just kita tengok elektron je yang keluar emit. So tiba-tiba dia kata boleh juga positron yang keluar. So maksudnya positron ni adalah antipartikel kepada elektron sebab charge-nya adalah berlawanan. Okay. So a positron is identical to an electron except that it has a positive charge. To be precise, the emission of an electron we can call it as a beta minus decay, and the emission of the positron we can call it as a beta plus decay. So kalau kita tengok perbezaan dekat sini, beta minus decay and beta plus decay hanya pada dia punya charge of proton number tu lah. Maksud saya untuk elektron dia akan negatif 1, untuk proton dia adalah 1. Untuk beta plus elektron positron dia adalah 1. Okay, sama juga. So dan kalau kita perasan dekat sini dia ada kawan dia. Okay, kalau example untuk beta minus, so dia akan kawan dengan antineutrino, and then untuk beta plus equation dia ada kawan dengan neutrino. Okay, the symbol of neutrino like this, and this one is antineutrino because we have a like sign vector dekat atas dia tu. Okay, so neutrino and antineutrino. Okay, experimentally, however, it's found that the most P plus particle do not have enough kinetic energy to account for all the energy released. So, beta plus particle carry away only a part of the energy, where does the remainder go? Okay, so dekat situ dia nak cakap lah mana lagi selebihnya energy yang pergi. Rupanya, bila dia buat propose that the part of the energy carried away by another particle that is emitted along with B plus or B minus particle, so call it as neutrino. Ni sebab neutrino jadi dia B plus lah. Neutrino B plus lah. Okay, then the neutrino has the zero electric charge and indeed it has a very small mass lah. Okay, the mass of neutrino is less than 0.004% of the mass on electron. Maksudnya sangat kecil lah. Okay, it's extremely difficult to detect because it interacts very weakly with the matter. Okay, so existence of neutrino is a must in order to obey the law of conservation of energy and angular momentum. So, to account the missing energy in positron decay. Jadi, that's why dekat equation, kalau you perasan dia ada beta plus dengan beta minus, macam dekat atas ni, dia mesti include sekali neutrino dan anti-neutrino. Sebab nak balancekan balik dia punya law of conservation of energy tu. Okay. Okay, next is gamma decay. So, gamma ray are photon. As you know before this about photon in electromagnetic radiation, they have a very high energy. So, emission of gamma ray does not change the parent nucleus into the different nuclei since neither the charge nor the nucleus number is changed. Okay, so gamma ray is a photon. Gamma ray photon is emitted when the nucleus in an excited state made a transition to the ground state. So, kalau you perasan kat sini, untuk kita buat equation yang melibatkan gamma ray decay, means gamma decay. So dia ada star dekat dia punya parent nucleus tu. Okay, so means that excited state of the nucleus, dia decay become more stable nucleus. Macam tu lah nuclei. Okay, so is there any difference between gamma ray and X-ray? They are both have electromagnetic radiation photon. Through gamma ray usually have a higher energy compared than X-ray. So the range of energy overlap to some extent. The difference is not in straight lah. When we use the term of X-ray, if a photon is produced by the electron atom interaction and gamma ray is the photon is produced in a nuclear process. Okay, berbeza proses sajalah. Okay, so ingat untuk gamma decay dia more daripada excited state of nucleus decay into the more stable nucleus. Okay.